Hi, my name is Tanya, and in this video, our polymer of interest is Kevlar. First, Josh will talk about what it is and its chemistry. I will be talking about how it's made. Jacob will explain the processing. Cole will discuss strength and durability. And finally, Eli will go over the advancements in applications through composites.
So, what is Kevlar? Kevlar is a synthetic fiber that has a high strength. It has many applications today in many different fields, ranging from military to industrial to commercial use. Such uses include bulletproof vests, sails, ropes, and puncture-proof tires. So, our topic of interest in regards to Kevlar is, what are cheaper alternatives to using sulfuric acid in the production of Kevlar? We plan to answer this question through study of chemical alternatives to sulfuric acid. We would also study how similar polymers are made to see if their methods are applicable to Kevlar manufacturing. The end goal is to find a more cost-effective production method that is practical for large-scale manufacturing. The first thing to understand about Kevlar is the chemistry of Kevlar. Kevlar, better known as polyparaphenylene terephthalamide, is a synthetic polymer. It is made in a condensation reaction of 1.4 phenylene diamine and terephthalol chloride. A byproduct of the reaction is hydrochloric acid. Sulfuric acid is used in the reaction but is not consumed by it. Sulfuric acid is specifically used to keep water-insoluble polymers combined during synthesis. This chemical is expensive to use due to its dangerous and extremely corrosive nature. It is extremely dangerous because of its corrosive nature, because if it gets into contact with metals, it is capable of producing explosive gas. To give a better visualization of the reaction, here is a picture of it. On the left side, you can see the reactants from left to right that are 1.4 phenylene diamine and terephthalol chloride. On the right, you can see the polymer that is Kevlar. And in the middle, you can see that there is a byproduct of hydrochloric acid that is produced during this reaction.
How Kevlar is made isn't too complicated. As Josh mentioned, it's synthesized through polymerization, a condensation reaction of paraphenylenediamine and terephthaloyl chloride. The yielded product is called polyparaphenylene terephthaloyl. This product is a liquid crystalline polymer. Kevlar yarn, which is woven to make Kevlar fabrics, is produced through the extrusion of this liquid crystalline polymer. In the next slide, Jacob is going to explain in greater detail the processing of Kevlar.
Kevlar is produced through a process called wet spinning, and in order for wet spinning to work, the polymer solution has to be dissolved in sulfuric acid. This not only because the monomers are not water soluble, but the final product, the Kevlar itself, cannot be melted. It actually chemically degrades at around 500 degrees Celsius. So in order to maintain its fluidity, it has to stay dissolved in the sulfuric acid solution. That solution is pushed through a filter and then pumped out of a spinneret. And essentially what the spinneret does is it extrudes long, thin strands of the Kevlar polymer. And these extrusions are aligned in such a way that hydrogen bonding between the chains is promoted, giving a higher level of crystallinity and also strengthening it. The resulting strand is run through a precipitation bath to sort of cool off the Kevlar and wash all the sulfuric acid off, and it is then wrapped around a spool and sent off to commercial brands that make the final product using the Kevlar. And those products could either be anything from like ropes to police vests.
Kevlar is fairly well known around the world for being an extremely tough material. One of the most well-known uses for it is for lightweight bulletproof vests. The alignment and spinning process allows the fibers to form strong interchain bonds, which helps the tensile strength reach around 3,620 megapascals. When spun into sheets and stacked into multiple layers, It can stop a bullet traveling at speeds of 380 meters per second and even more, depending on how many layers are used. The fiber chains that make up Kevlar form planar sheets with extremely high tensile strength. This is why the layers of Kevlar are able to withstand the full force of a bullet. The fibers are also very popular in use of making rope. Certain ropes have been strength rated to be able to hold up to 1,500 tons. The chemical structure allows for extreme heat resistance of around 450 degrees Celsius and no loss of strength until extremely low temperatures around negative 196 degrees Celsius. Kevlar can withstand moisture and even a wide array of chemicals other than strong acids without degrading the fibers. The main disadvantage is when exposed to sunlight for extended periods of time, the fibers can begin to lose color and strength. The GIF in the top right corner shows a bullet striking a Kevlar type material. You can see how the material is able to completely absorb the impact of the bullet, and the bullet does not penetrate it at all.
The recyclability of Kevlar. Kevlar is nearly 100% recyclable and can be reused multiple times. Some of the reasons Kevlar may need to be recycled is if it's been damaged, exposed to harmful chemicals, or if it's too old and has lost its integrity. In body armor, this is usually around the 5-year mark. The critically damaged sections should not be used in the recycling process as well. To begin the recycling process, you must first strip Kevlar from the other materials, then cut it into small fibers. The image on the screen is a piece of the cut Kevlar fibers. After this, they can be processed again and then made into new products. Recycled Kevlar cannot be made into body armor again because of the safety concerns. It can only be used in other non-ballistic products such as tires, cables, gloves, etc. Kevlar is important to recycle because of the growing uses of this material and the opportunities it holds in further research. Kevlar is mostly eco-friendly. If it is not disposed of properly, Kevlar can be very hard to destroy and will take a very long time to decompose in a landfill. That's why one of the numerous companies that specializes in recycling of such materials should do so. Another hazard to this process that can be easily avoided is the safe and proper use of sulfuric acid during the processing of the recycled material. If the correct procedures are used during the manufacturing and recycling, then Kevlar is safe for the environment.
Advancements in the application of Kevlars have been specifically pertained to composite materials, 2 examples of which are fiber metal laminates and fiber reinforced plastics. The non-Kevlar component of the FMLs and the FRPs, they oftentimes vary. It can be a variety of different plastics or metals, and Kevlar itself isn't always used in these composites, but it is commonly used in these composites for aerospace and commercial airline applications. A couple examples are the Boeing 767 and 777, and then the Airbus A310 and A340, which both, like I said, use composites, especially in the wings here. So you can see that 50% of the airline is made of composite. This is the Boeing 767, and Kevlar is commonly used in composites, like I said, especially in the edges of the wings. And Kevlar's advantages in composite materials include, providing a higher tensile strength and toughness, and significantly reduces the weight of the applied material, which otherwise would just include purely metal. So adding Kevlar definitely, as discussed before, in Kevlar's properties helps reduce the weight. In addition, FRPs are commonly used in naval applications. Here's a couple ships which belong to the Swedish Royal Navy. Kevlar is used on the superstructures of these vessels and a lot of times in the decks of the ships, so that the deck and the structures which endure high levels of heat and pressure can withstand these withstand these elements and will not collapse in on itself.